everybody, welcome to this talk. And I'll start by introducing us. It's also very nice to see so many people. I'm Echzell&Sylvarnes. I work at the Norwegian digitalization agency, which is a tongue twister, and I work with data sharing and data governance in the Norwegian public sector.
Yeah, and my name is Echzell. I'm a student at the University of Oslo, but I'm also working in the IT department at the University of Oslo in the Linux team. And together we wrote a little paper called Interoperable Infrastructure for Universities, but also enterprises in the public sector that we would like to talk about today. To motivate what we're talking about interoperability, specifically in the university sector, I brought a little story because some time ago I was going to study abroad. As most of you might be familiar with the Erasmus program. I was going to study in Oslo, and that usually means you need to fill out a lot of forms. For example, such a learning agreement, where you kind of write down which courses are you going to take. That means I went to the website of the University of Oslo, I checked all the courses, I figured out these three might be interesting. Then I manually copy-pasted the course code, the title of the course, the relevant semester, terrible semester, which is after Corona, and the ECTS, which is the European standards for study points between this form. That wasn't that hard, it was a bit manual, but then I needed to get 3 signatures from different people. The first one was myself, and then the Erasmus coordinator at my home university needed to sign, and then another coordinator at the University of Oslo. And that's where it became a bit tricky, because it shouldn't be too hard, but pretty much everything in this entire process is in email. What you see here is only a tiny fraction of all the emails I sent and received throughout my 3 semesters Erasmus journey. This is only part of that before I even could take the first course, get all the paperwork done. And why is it so many emails? Just for me as a student, because I kind of have the additional task side of studying and going abroad. I need to relay a lot of these emails. I need to send a lot of emails and say, hey, I got this form, can you please sign it and send it back to me? It takes a week, and then I send it to the next person in another country, then I need to sign it myself, hope that everybody agrees. And when the last person in the chain doesn't agree, or when the course admission, then of course doesn't talk to the Erasmus coordinator, says, well, nice learning agreement, but the course is full, then you start over. Maybe you need to change something in the middle of the semester, and then suddenly there are thousands of emails. And things get worse. Because in 2017, French President Macron held a speech and said, well, we should kind of scale up this mobility program. There shouldn't be only one university that the student is attached to, and then you may be taking a travel for some period of time. But we should have something like university alliances, meta-universities in a way, where students are enrolled with many universities at the same time, and they form an alliance, and it's just a fluid, you can take courses wherever you want to, and it's going to be super nice and international and European. And that sounds great. It's probably a nice experience, but it's probably also going to be something like that. Because that was in 2017. Nowadays we have 65 different university alliances with on average like 8 to 9 member universities. And I envision if we don't change the technology to actually make that kind of work, this is going to be terrible. It's just going to be a combinatorial explosion. But in order to make the process better, we kind of first need to understand why is email so popular? Why is everybody thinking we should use that piece of technology? And that's probably because, everyone has it. It's kind of a standard. And why did it become a standard? Probably that's because it's interoperable. That means historically different universities or just organizations in general, organization A could say we are running a service that by chance supports the SMTP protocol, and organization B might say the same. It might not be the exact same service, but through interoperability these services can kind of talk to each other. And by that, if you're an organization of sufficient size, there's quite a high probability that at least some software in your stack talks SMTP. By that, you suddenly have a network effects and stuff like that. Suddenly, everybody has email. And the European Union had a look at that and thought, that looks like a nice concept, interoperability. We should mandate it, and they did. Now with the Interoperable Europe Act, some of you might have been here 2 years ago where Lina from Free Software Foundation Europe talked about that when it was still in the process. And now it's in force, in the EU at least, not in Norway yet. And they came up with a concept of interoperability solutions. That might be on different levels, that might be legal or organizational, like the GDPR, where standard contractual clauses might be seen as legal interoperability solutions. Or maybe the Bologna process and the concept of ECTS as an organizational or also legal interoperability solutions. But there's also these semantic and technical levels mentioned in the law. And in that way, we might say that SMTP is a technical interoperability solution under that act. And now you might talk to your boss and say, we need to become more interoperable. And your boss might say, can we just use Microsoft Teams? Because in their marketing, they say you can just add people from outside of your organization and everybody's using it, and that should work great. Is that not interoperable? And you might say, well, kinda. Difficult to argue against that, because if everybody's actually using Microsoft Teams, things would work out fine, I guess. And even though the Interoperability Act has a soft preference for open source, I guess Microsoft might try to market themselves as such an interoperability solution because of that sort of functionality. And I guess I don't need to convince you, but if you want to take some arguments home why this might not be a good interoperability solution, at least, I mean, let's see what happens if a lot of universities take that choice. That means we'll have centralization, maybe with Microsoft or any other Silicon Valley company or a daughter company or a US company at least. And then there's this guy, and the Cloud Act that you might have heard about, and a guy with at least some unstable behavior, giving himself jurisdiction about data centers in the entire world. We don't want that, I guess. There's money, because centralization also means dependency. If all universities use Microsoft Teams and your only chance of talking to your peer organization is also using it, what are you going to do? Either you pay money or you're not talking to them. So you pay money. Your negotiation position is quite bad if a centralized solution actually becomes the default across a large ecosystem. And then there's also Max Schrems, the face behind the Schrems 1 and Schrems 2 verdict, where the highest European court multiple times has that, like privacy law in Europe and the US. Two entirely different ways of choose, and to be careful, let's say at least there's a legal gray zone when you send personal data of your students to US companies. So what do we do? Do we need to decide between centralization and dependence, or boring old email on the other side? And we think there's a third way, which is why we're talking about interoperability today. And we're going to use this University Alliance as a kind of case study. Even though what we're going to talk about today is going to be applicable in a lot of different use cases and a lot of different organizations. We're going to talk about three things. The first one is basic messaging. We'll just talk to somebody. The second one is sharing files, which we usually do quite often. But then we also might want to construct domain-specific solutions with some common sort of semantics, and that's what Terje is going to talk about. Let's start with basic messaging. I guess a lot of you have heard about Matrix, and by the way, we're only bringing up examples to show interoperability is possible. These might not be the best solutions for you, so come with your own thoughts. We're just presenting examples here. If you haven't heard about Matrix, well, they say they are a set of open APIs for decentralized communication, which is quite broad. But I guess the killer application for that is some sort of messaging service that looks a bit like Slack. And Matrix is several different things. It's a client-server API, so your program or your phone or whatever now knows how to talk to a server. But what's really interesting is this part with the server-server API, where one server also gets some sort of language to talk to a different server, which might look familiar if you know how email works. And when you have a lot of servers talking the same language and form a network, We also talk about the federation, and user IDs in such federation usually have a common structure. You have a username and identifier for the service. If you want to send us a message, do it on Matrix. The cool thing is, since the client-server API is also defined, it opens up for support for end-to-end encryption, since you can pretty much define how the endpoints are supposed to work. To the user, you don't see that complex network. You just see a user interface. I think it's quite clean. It looks pretty much like Slack. But the good thing, again, is we have a lot of different people here from the science mesh community, from completely different organizations running their own Matrix server to some extent, and they can talk to each other as if they were part of the same organization. Next use case, we don't only want to send messages, we also might want to share files, and I mean you can do that in Matrix, but it might be better to use something actually made for file sharing, and that's where Open Cloud Mesh comes into the game. Open Cloud Mesh is only a server-server API, doesn't really specify how to talk to clients. Maybe raise up your hand if any of you is using or self-hosting any of these services on the side. Maybe a third, so quite many of you. But I guess all of you have heard about Nextcloud, OneCloud, cFile, OpenCloud, any of these. And the good thing is all of these implement Open Cloud Mesh. What is that? Well, pretty much some sort of extension to WebDAV or much more, some sort of authorization flow where one server says to the other server, hey, I got a resource for you. WebDAV is mandated, but it might be a lot of different resources. Would you like to share this resource with a defined set of your users? And again, you get such a federated Open Cloud Mesh address, and I as a user can just go ahead and say, I want to share this WebDAV share with somebody at another organization. And because both servers are talking Open Cloud Mesh, it's going to work out. How does it look? Pretty native, actually. This is my personal Nextcloud when Terje and I worked on the presentation here. And I mean, I could just share it with the user on my own Nextcloud, and Terje could have an account, but that was too complicated because Terje already has his own Nextcloud. We hide the name here, but I can just share this file with Terje at his own cloud, and you just see it's a remote. It's not a native user, but it looks quite native, right? I can just put in the federated cloud I did there and share it. So now we've seen two very basic use cases, messaging and file sharing. But at some point, I mean, it would have been much easier to fill out that form I showed you in the beginning if we had that. I could just put my file into a folder and say, please sign it, and then wait for a couple of days, and then I take the file and it's just signed by different people. But at some point, we would like to build domain-specific solutions that would work much better than just passing PDF files around.
There we go. So you could say fundamentally there is a question of how to share data in this situation of Hagen relaying all these emails between coordinators. And in this case, it's a file sharing or data sharing over email, which is quite suboptimal. So I want to present a small scenario, all imagined entities, so no one named, but let's imagine that I and Hagen are studying at one of these universities, which is part of an alliance. And they want to display all the courses they offer for this university. Let's call it the University of Interoperable, which we are studying at. They want to show all the courses from the different universities as part of their own course catalog, which also could be part of simplifying one of these processes which are involved when applying for an exchange, for instance. So it might look something like this, for instance. You have to apologize for my Figma skills, but as an example. So we see this is the course catalog from the University of Interoperable, and there we see 3 different courses from 3 different universities gathered in the same place. And let's say that you are the developer who are assigned this task of implementing this. So you might go ahead and maybe write some crawlers, you consume some JSON APIs, you get along, it somehow works. get a bit sense of frustration, you know, that it should maybe be easier to do. And then you get to number 8, the 8th university, which we can call the University of Interoperable. And they have this JSON API for the course data, where nothing is what it seems, nothing makes sense. The no name contains some text. The English title definitely doesn't contain any English text. Then you have some cryptic keys and an X and Y, which like what are these? And then you try to find the documentation. So you visit this URL which you find, which of course isn't available. Then you fall back to the email, right, and try to contact the help desk of the University of Schmidt, only for a week later to get like a non-reply. Also, it would be nice with the chat room here, for instance, a shared chat room between this University Alliance, by the way, talking about Matrix. So in this situation, there are some very obvious issues, right? First of all, there's the scaling issue. And in particular, if all the universities were to do this in the same manner, right, wouldn't work at all. Then it's also very brittle. It doesn't take many changes to the HTML structures for the crawlers to break, or changes in the JSON APIs. Maybe it's even JSON APIs which weren't meant for external purposes even. And there's also some ambiguity. Are we talking about the same thing? What does X mean? What does Y mean in this JSON body? What is English title when it doesn't contain English? So some common solutions to this would be, or one common solution would be to agree upon a shared API, a common API, right? But there are two issues, and the first one is that you either have to do minor or major refactorings of existing APIs, or you would have to implement and maintain a separate API in parallel with the existing one, which also has its own issues, right? So instead of that, what if, with this JSON body from the University of Schmidt, what if they had assigned each key a definition from a common vocabulary, which is included in the JSON object? And for this purpose, and as an example, we are going to use the schema.org/course, which is also available as a web resource. And we are going to use the properties, name, description, and number of credits, as they have defined. But you could use any common vocabulary that you agreed upon in this University Alliance. Just keep that in mind. So this is actually possible with the help of something called JSON-LD. And maybe raise of hands, how many here knows about JSON-LD? Some people, okay, that's nice. So JSON-LD stands for JSON for linking data. And if we add the context and make this a JSON-LD document, it will look like this. So there's some text, we'll go through it one by one, but just notice that the only thing we've added is the context object and an ID and a type. And otherwise the rest of this is the same as before. And the first thing we define is that the type is this resource, so this data is of a course type, as defined by schema.org, which defines it as a description of an educational course, plus. And from this we can define, for instance, the no-name key to be of the schema.org/name property. And then, crucially, in English. So this key actually contains the English name of the course, as defined again by schema.org. Same goes for the English title key, which apparently is the Norwegian name, as defined by schema.org. Then you have this DSPT, which is the description in English of the course, again, as we can see, as defined by schema.org. And the Norwegian description is given by this very cryptic key, which is a Norwegian abbreviation. And then finally we have the Y, which is, as you can see here, is the number of credits as defined by schema.org. This might be an instance where you actually would want to refer to something which unambiguously defines the ECTS, European system. So, because we don't get information on if is this old Norwegian credit system, is it the American one or the European one? But and then finally, this might be a homegrown custom vocabulary which the University of Schmintrop have defined themselves, which is also possible. So you can reuse resources on the web or make your own and publish them. And then finally, you have an ID, which is a URI, which is global in scope, right? Which makes this also possible to identify across organizational boundaries and across boundaries of the different systems. And it should be persistent and also unique. Yeah. Okay, and all this is defined in the JSON-LD specification from W3C. So they also define some operations you can do on this format, or data in this format. For instance, the expand operation, which looks like this when you apply it on the course data. So just notice that this operation removes the context objects and then replaces all the, if you want, local key names with the ones unambiguously defined in the context. Right? So the no name is removed and replaced with the schema.org/name. And then you have the values for the different languages. The same goes for the other values as well, or the keys. Sorry. Which means that this gives us a more, maybe as a layer of abstraction almost, because you can disregard the local API key names. And this can also be seen as a graph, also known as RDF, which JSON-LD is a serialization of. So, and keep in mind also that RDF graphs aren't necessarily DAGs, they can be cyclic as well. And the properties are named. And these graphs might have several different representations in JSON, because that's a tree structure. You might want to sort of reshape this and fit it to a structure which suits you more well, or better in your case. This is also possible to do with something called framing in JSON-LD, which in a way resembles a query, graph query, you might say. So in our case, we are interested in only the English name and the English description and the number of credits from the course data. And we would like to disregard the Norwegian values. And that is possible by defining this frame, which is also JSON-LD, by the way. And then we apply it with the frame operation on the course data as JSON-LD and get this in return. So here we see the English description, the English name, and the number of credits. So this has some benefits. When you add these definitions or add semantics, if you want to, whatever you want to call it, it gives some kind of built-in documentation, right, in the data object, which hopefully will give better developer experience. It also reduces the amount of ambiguity on what the data elements actually means, right? Because you can base it on a shared vocabulary where there are definitions written out, and they are tied to the data itself. We also have a shared model, which handles several, as long as you treat or consume the data as JSON-LD, you can handle quite a lot of changes in the JSON API, key names for instance, and some structural changes. It scales better, I would say, because you can treat this as a sort of uniform interface for consumption. And since it's RDF, which is also supported in HTML and other data formats, that has more applications. JSON-LD is still ordinary JSON, so we would argue that you get the benefit of local flexibility while also getting better interoperability. So maybe you could think about this as a sort of lightweight standardization, as an alternative to one-size-fits-all solutions. And we also would encourage you to think about and define your concepts around it when creating software, by stating what your data means. And also, it creates a shared understanding of these domain concepts, and you can tie them together and allow, for instance, for domain experts to participate in the discussions of these definitions and create a connection between domain experts and technical layer, and the data layer.
Yeah. To wrap up, what we presented today were a set of interoperability solutions. We had two technical interoperability solutions, which were Open Cloud Mesh to share files and Matrix to send messages to each other.
And then we had a use case of using JSON-LD to add semantics to your data based on a shared vocabulary, the schema.org, or maybe your own homegrown, whichever.
Yeah, and to finally wrap up, last slide. Question is, should we put interoperability maybe first, or at least early in the process? Because we've long gotten used to including users in the development process, right? It's really important to understand how users interact with a given service at an early point in time, and to not do that all the way in the end. But what we also should discuss quite early in the process is how systems should interact with other systems in this sort of network, right? So on the main track, Jus is talking about an open source alternative to Microsoft Teams. And he's talking about Nextcloud. Nextcloud is a great solution. It is implementing Open Cloud Mesh. But maybe we, as an open source community, should not discuss solutions first. But rather, the alternative to Microsoft Teams is a set of standards, a set of ways to talk to each other. And maybe Nextcloud is going to be a great reference client to implement all of these standards. So let's shift our discussion a little bit towards interoperability and not only code and source. And if you'd like to really go in depth, we're going to publish our little paper along with the slides on the foss-north homepage. Thank you very much.
Questions or one question? Yeah.
So I was surprised to see that the EU has this initiative for increased operability. Considered that my impression is that the interoperability landscape looks very barren. I mean, looking at Matrix, for example, we have like they have financial issues. I think with the exception of Nextcloud, like everybody who wants to do something like this faces the problem that nobody is paying for it. So what is the imagined route that the EU sees for people like me who really want to make interoperable software? Like, how am I supposed to do this, make the EU very happy, and also live off of that? What's does anybody is there anybody who has an idea for how in theory that is supposed to happen?
As far as I know, funding issues are not really discussed in terms of that Interoperability Act, but we discussed a couple of ways how this sort of interoperability discussions could take place, and that might be, official discussion forums where people might discuss on a high level which kind of, in a political way, which kind of interoperability they want and how to fund it. But that might also happen a bit more implicitly. For example, the German Open Desk, where pretty much the German state says we want to use these solutions, we want to use Matrix and Nextcloud and whatever, and in an implicit way, I mean, by that they are funding these organizations that are supporting and developing that, but also implicitly they shape the understanding of this is the standards we're using inside the German state, for example. And implicitly, OCM and Matrix are going to be standards that play a major role in that sort of context. But yeah, these questions are usually not discussed that much together. It's usually interoperability here, funding separate place, which is sad. Yeah.
I think that's what we've got time for, but please reach out. We are available for the rest of the day. Thank you.